I'm Museum Guide Randy Bolt, and today we're going to bring you part 2 of our popular rock cycle program seen by thousands of 4th grade students over the years here at the museum. Thank you all for doing your part to flatten the curve and practice your social distancing and avoid crowds. But hopefully sometime when the museum reopens, you'll be able to come on up and see all of our beautiful displays up close and personal. But today, as I said, we're going to be finishing part 2 of the rock cycle. Yesterday we learned about minerals and their beautiful crystals, which can be very valuable, being the ingredients of rocks. And we talked about the 3 types of rocks, including igneous rocks, sedimentary and metamorphic. And yesterday we learned about the lava rocks, all different types, basalt, rhyolite, and how some of the different kinds of igneous rocks cool underground though. And we left you with a little question yesterday was, well, if these granite rocks that are igneous, which are deep underground, how come we can go up into the mountains and see these beautiful giant granite peaks? How did nature somehow move an entire mountain of volcanic rock out of the way so that we can see? If anyone wants to comment in on that, go right ahead. Now, actually, this is where the water cycle, that's a big hint, comes into play. Because we know volcanoes can make rocks, but how do we unmake rocks or take rocks away? Well, the answer is erosion. Erosion breaks down rocks, even the toughest, strongest rocks, and wears them away and turns them into gravel and sand. And then we have it washing them away. So basically, volcanoes make mountains, erosion takes them apart. Now, what it makes is what we call sediment. Sand, gravel, mud, clay, that's sediment. And it washes away, and where does it wash to? Well, I'm going to give you a hint. It doesn't go uphill. It washes downhill. So water and wind can weather and break down rocks, wash them away. Well, those rocks wash away and they pile up somewhere. Well, where do you think they would pile up? Maybe in a river? And the river would take the rocks and the sand down to maybe a lake or maybe the ocean, and all of that sediment starts piling up. Well, over millions and millions of years of piling up sediments in bays and oceans and lakes and rivers, eventually the ones at the bottom are under great pressure and they get kind of glued or cemented together, and that would make sedimentary rocks. So sedimentary rocks we'll move on to here. Let's move our igneous rocks out of the way. So we can see that erosion in the water cycle is very important for moving around rocks and minerals. And we'll look here at a few of the more common sedimentary rocks. Now, as fine mud or silt gets washed down and becomes a rock, well then it turns into what we call shale. Not the most exciting rock in the world. Its nickname is mudstone. Another one that we have that we find a lot, what is sand is formed into a rock. Well, that makes sandstone. And this is kind of a cool sandstone. This is what they call picture sandstone. It's from desert areas, and the sand kind of made dunes and stuff, and it makes really cool little patterns and shapes. It looks like landscapes. Now, sandstone is not very strong. It breaks pretty easy. Sometimes you can scrape off the sand pieces, but it's pretty. Sometimes they put it on the outside of uglier buildings. Now, if gravel gets welded together and cemented into a rock, we call that conglomerate. So these are sedimentary rocks. Some of them are useful. One of the most important sedimentary rocks is this one here. This is called limestone. And limestone is a very, very common rock. But believe it or not, this is one of the most valuable rocks for making money in California. We make more money off this than gold and silver and other things. It's just a plain ugly rock. Now, do you think it's highly expensive? It's not. Limestone is very cheap. It's only about $200 for a whole truckload of limestone. So how can we make so much money off of it? It's not exactly beautiful. Now, it does come in a lot of colors, and limestone comes from areas where there were oceans or shallow oceans, and a lot of different mud down there turns into limestone. Well, we actually crush the limestone up into this gray dust. Anyone know what this dust is? We sell tons and tons of it because it's very cheap. Well, this gray dust, you might go to your hardware store and try to find some of that. You might buy a bag, and if you brought it home, you would mix it with water. Anyone know what that is? Want to text it and let us know? Well, basically, when we mix it up with water and leave it, it will get hard and turn into concrete. It's kind of a man-made rock. So crushed limestone makes cement, and then when you mix it with water, it hardens into concrete. So this was very important. The ancient Romans had learned how to make concrete thousands of years ago, and we make all kinds of things. Just for fun, think of all the things you could make out of concrete. And when you use concrete, you usually don't use a little bit. Think freeway overpass, think a mile of curbs and sidewalks, think a swimming pool. So we use lots and lots of concrete. And then what do we add in with it? Gravel and sand. We actually make more money off gravel and sand than we even do off cement because it's cheap and we use huge amounts. So we can see some sedimentary rocks are very valuable. Here is another thing that's very cool about sedimentary rocks. What if when the mud or the sand or the gravel was changing into a rock, it had dead creatures in it? Well, then we might get fossils. Here we can see there's shells, fossil shells in the sandstone. Here's shale with fish bones. Now, only things that are hard like bones and shells will transform into fossils. But fossils help teach us about the past. Here's another one that's cut open and you can see the seashells that got cut through. And we know what there used to be an ocean here if there was fossils like this. Sometimes we find fossils of plants too. This is a fossil of a sequoia leaf. And we found this in the desert, so we know giant sequoia trees used to live here. And so fossils, besides being worth a lot of money for some people that will buy them, they help us learn about the past and what kind of environments were there. So sedimentary rocks can be very useful. Now, the interesting thing is, when you think we need a lot of erosion to create sedimentary rocks, but they form deep under oceans and lakes. So then later, we need much more erosion after the ocean dries up to erode it away where we can see these sedimentary rocks, just like erosion had to expose our igneous rocks. All right, now, sedimentary rocks are very neat, but the last type of rocks we're going to look at are right over here, and these are metamorphic rocks. Now, metamorphic rocks started out as some other kind of a rock, but then with tremendous amounts of heat and pressure, they were changed. And it actually causes the crystals and the minerals in the rock to go through changes. They may get new minerals added in, certain minerals may be removed, or they may be changed. Now, if we have shale, which is mudstone, and it gets changed into a metamorphic rock, it makes slate. Slate is much stronger and tougher than shale. It still breaks in layers, like a lot of sedimentary rocks do, and you can see it's kind of thin. Well, slate is excellent for stepping stones or roof tiles. If you're going to have a castle and you have fire arrows coming in from your enemies, if you have a slate roof, well, that's really good shingles. We still use slate today for roofing. It's very expensive, though. So slate is a useful type of metamorphic rock. If sandstone, which was a sedimentary rock, changes into metamorphic, it becomes what we call schist. And schist can be all different colors, just like sandstone. But again, this piece of schist weighs about twice as much as it did when it was sandstone. It's been squished really tightly. And I don't know if you can see, but here we have some big chunks of copper pyrite or chalcopyrite. These crystals formed when the sandstone was changing into schist. And that sometimes happens. We find things like rubies and garnets and things very valuable sometimes in schist. It's hard to break them out. So schist is another type of metamorphic rock. Most metamorphic rocks are tougher and stronger than what they used to be. Not always. Now, another metamorphic rock that we have around here is greenstone. It used to be basalt lava, but it got changed. But this also shows us something else that's very interesting about metamorphic rocks. Sometimes very, very hot water can dissolve minerals, and those minerals can go into a crack. And then the whole rock gets heated up and becomes metamorphic. But the hot water in those cracks can bring other minerals. And then when everything cools off, those minerals form a vein. Now, white quartz is the most common mineral, or feldspar, that gets in these veins, which isn't so exciting. But what else do you think might get into those veins? By the way, what do you think would make underground water super, super hot anyway to cause these changes? Well, what causes it to get super hot is underground magma heating up those rocks. Now here is a piece of white quartz, It was a vein just like we broke out of that other one. And it's just mostly white quartz. We don't really see any crystals. By the way, when a mineral just makes a big chunk like this, doesn't make any crystals, we call that massive. Like here's a quartz crystal. And here's just a chunk of massive quartz. Doesn't have crystals. But this is massive quartz. But if we look at the other side, it's full of gold and pyrite. Now, unfortunately, there's more pyrite than gold. But a lot of times, these crevices and hot fluids bring very valuable minerals. Gold, silver, copper, other metals that we need to use. And they're in the rock. Now, if erosion breaks these rocks down, then all that gold and silver will go into rivers and creeks. Here we've got our copper and our copper pyrite. But let's take a look. Here's some gold like the 49ers would have got in the gold rush days. I don't know if we can see that. It usually shows up better under a dark. Can we see that gold? But this is what the 49ers would have found. Little bits and pieces of broken up gold. Now gold is one of the heaviest things in nature. And so it's hard to wash away. And it will stay in the rivers and creeks. And the 49ers found lots of gold, even nuggets. But the most of it is pretty small, smaller than rice grains. Well, what if the gold is in a rock like this though? The 49ers did not have a way to get that out. How would you get the gold out of this rock? Well, we had giant mills to smash and crush the rock, and we can pull out the stuff we want with chemicals. Sometimes we melt the rock, and the part we want will go to the bottom. But basically, most of the gold we get is not loose in the creek. It's in rocks. Just like other metals, we smash them up. A rock that has something valuable like iron or gold or silver, we call ore. So this would be gold ore. Now, sometimes though, when these crystals are inside of quartz, what would the gold crystal look like if we could magically make the quartz go away and not have it all eroded down by nature, but we could just see the gold crystals? Well, those are very, very hard to find. But in today's world, we have modern technology. We can dissolve away the quartz with very strong, dangerous acid and leave the gold crystals. Because gold crystals are not really bothered by hardly any kind of acid. We're going to go over here and I'll show you we have a piece of these beautiful gold crystals which has been removed from the rock. Mike's going to zoom in as much as we can there. So that piece of gold that's hanging out, we wouldn't normally ever see a piece of gold like that just laying there. It would have broken off. But right now with the acid etching to remove the quartz, we can see beautiful gold crystals. Now that gold right there is worth about 5 times as much as a beautiful crystal for a collector as it would be if we melted it down into a blob. Gold is worth a lot of money, but gold crystals are worth way more. And the bigger they are, the more they're worth per ounce. We also see our state mineral, gold is our state mineral, pardon me, for California. Our state gemstone is bonitite, one of the rarest gems on the face of the earth. And you can see that here at the museum. But then 1 or 2 last rocks I'd like to show you. One of them is our California state rock, which is serpentine. And we find that in places where the earth is crashing together. Let's go back over here for a minute and we'll look at a couple of another serpentine rock. But in places, some parts of the earth's crust squish together, and one part will sink down below the other part. And where the huge crushing together makes a lot of pressure, and dark minerals from deep in the earth's crust come up, and they make serpentine rock. It's usually very dark green like this, but sometimes it's real shiny and light green. It can be beautiful, but it's not very strong. We don't really use it for anything, but it's considered our official state rock, serpentine. And it's kind of pretty to put in the garden and stuff. But serpentine is in the area where the California gold rush was, because this is an area where we did have parts of the earth crashing together. Now, sooner or later, any part of the earth's crust, whatever kind of rocks it has, is going to sink down under another part. And we call those subduction zones. And what's going to happen when the rock goes down deep enough into the earth? Well, it's going to remelt, and it's going to be magma. And then it can come back as lava somewhere else. So that's how the rock cycle finishes and repeats itself. So one last rock we'll take a look at here. This is a piece of rock named after our town where we're filming here. This is called Mariposite. And Metamorphic has this beautiful green colored mica mixed in with quartz and calcite. We can cut it and polish it. It's kind of pretty. So Metamorphic is a metamorphic rock named after Mariposa, where we found it. But there's a lot of it around California's foothills. So Metamorphic is an attractive garden rock too. Well, you guys have seen now that all rocks are made out of minerals. And minerals, if you're really lucky, can make beautiful crystals like quartz and our fluorite and all sorts of different minerals. But mineral crystals are kind of rare. If you're not a collector, then most of the minerals we just get by finding the right kind of rocks and crushing them up. And we learned that rocks formed by volcanoes are igneous rocks, like our basalt and our lava and our granite rocks. And some of those are useful. And we also found out about sedimentary rocks. Whoops, those out of the way. Like our sandstone and shale and limestone, made by sediments, washed down. And erosion is a big part of making and breaking them up. And then finally the metamorphic rocks, changed by heat and pressure, often very good for finding crystals and gold. Well, hopefully you've enjoyed our program, and if you have any comments, go ahead and message us on Facebook or check the museum website. But hopefully you're all going to continue to help flatten the curve, avoid the big crowds, but one day the museum will open up and you can all come and see our beautiful gold and crystals from all over the world. Well, this is Museum Guide Randy Bolt signing off from the California State Mining and Mineral Museum in the historic gold rush town of Mariposa, just west of Yosemite National Park. Thank you for watching. Bye-bye.